So we've been talking about shell models, and today we're going to start to talk about how atoms come together and form these really cool relationships. Let's start by doing the shell model, sketching the shell model for sodium. So if you take a look at the periodic table, the chemical symbol for sodium is Na. And upon closer look at it, what you will see is its atomic number, which is 11. So let's do the shell model for sodium. And so I'll go ahead and I'm going to kind of sketch it right here. So here is my atomic nucleus for sodium. Here is my first energy level. And let's remind ourselves, right? Our rules are 2 in the first energy level, 8 in the second energy level, and 8 electrons can go in the third energy level. So here's my first energy level. I have an atomic number of 11. So 1, 2. Now I'm going to go out to the next energy level. And I'm going to go ahead and place in, I kind of like to pair mine just so I can keep track of my numbers. So there's 3, 4, 5, 6, 7, 8, 9, and 10. But I still have one more electron to account for. But I have this second energy level now filled up, right? So I'm going to go to a third energy level. And when I get out to this third energy level, what's going to happen is I'm just going to put that 11th electron out there. And so here is sodium. If I look out that last energy level, I think you guys will all agree with me that there is 7 vacancies, 1 electron and 7 vacancies out here, right? So we can actually, let's kind of denote all the vacancies. So there are all the vacancies, 7 vacancies. Now, let's think about chlorine. Chlorine has the chemical symbol Cl. It has an atomic number of 17. So if I were to make the sketch for chlorine, what I would do is kind of again start with my atomic nucleus. I'm going to sketch in my first energy level. I'm going to put in my 2 electrons there. I'm going to go out to my second energy level. And let's see, 3, 4, 5, 6, 7. I'm sure you guys are much neater with this. 8, 9. I've got all of these filled up. I've got 10 so far, right? But I have 17 to account for. So I'm definitely going to a third energy level. So here we go. 11, 12, 13, 14, 15, 16, and 17. Now, if I take a look at chlorine over here, what I notice is it just has 1 vacancy. So what do you think happens when sodium and chlorine happen upon each other? Well, I think that chlorine says, hey sodium, I would be happy to take on your electron. And so that's exactly what happens. Sodium will give up its electron. There's going to be an electron transfer. So I'm going to transfer this electron over to chlorine. And when I do that, then what happens is sodium will have, this shell's basically going to go away for us, and sodium will end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So now sodium has 10 electrons, but nothing happens to the number of protons. So it has 11 protons. So if I think about it, its overall charge now is positive. So now I have not a sodium atom, I have a sodium ion, and it's carrying a positive charge. Let's take a look at what's happened to chlorine. Chlorine has taken on that electron. So now chlorine has 17 protons. I didn't change its proton number in any way, so it has 17 protons, but it will now have 18 electrons. So I think we all agree that now instead of having a chlorine atom, I have a chlorine ion, and it's carrying a negative charge. And what do we know about opposite charges? They're attracted to each other. So now these two ions are going to hang out together in what we call an ionic bond. So this is the first bonding pattern, and it is caused by these mutually opposite charges attracting each other. So these two atoms are going to hang out. Now, something else may come along and they may break apart and they may say, hey, this is more attractive to me at this stage of the game. But for right now, this is all I have on my board. They're going to hang out in an ionic bond. Let me know if you have any questions.